Hello. We are going to get started. I hope you had a great lunch. Welcome to this session, Working Together, part of the buildingSMART International Summit here in Berlin. My name is Tryfona, and I will be the moderator for this session. I am the chairperson of buildingSMART Greece, the Greek chapter, which is actually currently chapter information. And we are now going to start the third session of the day. And now we have a fantastic lineup of speakers who will share their insights on how embracing openBIM and collaboration can help us move the industry forward. So we have 4 presentations, each lasting around 20 minutes. And I would like to ask Claudia Szargan, BIM manager at Deutsche Bahn Fahrzeuginstandhaltung GmbH, and Dr. Daniel Krause, head of digital construction at Weiss und Freytag Ingenieurbau AG. They will share their award-winning work, collaborate to innovate, IPA, and big openBIM in real-world delivery, focusing on the new ICE maintenance plant in Cottbus, which was recognized with the BIM Champion Award in the construction category by buildingSMART Germany in 2024. Claudia and Daniel, the floor is yours.
Thanks for your introduction. I'm happy to present our project today, together with my project partner, Daniel. And we just jump into the project. That's the baby we are all talking about, the ICE4. That's a big train. It's more than 370 meters long, can inhabit more passengers than the ICEs before, German Rail, ordered 120 trains, additional to the other ICEs they have before. And all those trains need to be maintained. And we see the normal little maintenance may be done by the train operators, like doing little checks or emptying the toilets. But the main things that has to be done after 6 or 7 years, there's not enough resources within Germany. So it has to build a new facility. And that's where it comes to us. The company, DB Fahrzeuginstandhaltung, is maintaining German Rail's rolling stock, making the heavy maintenance for everything, like for diesel engines and for whole trains. And we have different places where it's done. And we do like a lot of maintenance, even redesign when the train's made new, or even overhaul of engines and everything that is done. And now in Cottbus we are building a new facility for the ICE4. There it is. We start with the first part. Oh, you don't see this. There's 2 maintenance hall we are building. The first has 2 tracks. It's more than 450 meters long, and we have the opportunity to take the train into it without separating it, and we can do everything on one track, so it's faster than before. The first hall with 2 tracks has been finished end of 2024, after not even 2 years. That's really fast in Germany. And the next is still built. It's a big one with 5 tracks and workshops and storage, and is still in building. And in addition, we also have to build new tracks, more than 20 kilometers. We need that for our facility, but also we had to take away tracks from the railway station over there. So now that's what we see. At the start, it was just a bit of dirt, a lot of contamination, all industrial area. And that was the beginning of 2023. And it moved forward with concrete columns, building technology. Here you see the maintenance parts already. And in the end, beginning of 2024, the train goes in and we were finished. And we had a big inaugurations. Even Bundeskanzler Olaf Scholz was there to celebrate with us. So we did this with a team really fast. The second that's just started already is the big one. Also a lot of dirt, columns, and big foundation. And altogether, we have 1 billion of euros are needed here to get this finished. And you see here the storage facilities, and we go into the main hall, where you see also like the service pits where the trains will be in, or also the facility, how it will be finished. So what is it done with, what's about the integrated project delivery and BIM? What's it about already? So this is a special contract form where you have multi-party contract with different people. The clients, the planners, and also the contractors are in the project from the beginning on and working on it, sharing risk, and moving forward together as a team. And how is it done? Of course, by the money first. We start the planning phase with the building contractors. So the planning is done by the planners, and the building contractors get their experiences, how they do, what suppliers they have, materials, processes, and they know what things cost. So they all plan it together, and in the end, we have a target design, a budget. That's the big pot where everything comes in, the costs, what you calculated, and also the risks. You have a budget for risks, and this is the big budget. In the end, after we are finished with the construction, you will see how much is still in the big pot, and if there's still money in it, it can be shared with everyone, so everyone has a profit. If not, we will see. So everyone has an interest to work together as a team as much as possible. These are our partners. One is over here. Weiss and Freitag is doing the engineering and the columns and construction building. We have ourselves. We have the partners for building technology and the one for logistics that's also doing like the storage and also the vehicles that's done, and 2 partners for planning. And how does it work? It's not only one team that's sitting together. We have one project management team that's doing all the main decisions. And then we have different teams doing the project realization teams, it's called. You're doing different parts. They are talking about how building it, how is it the planning. And we also have one team doing all the BIM process, making the standardization and working out how we do things together. And the first thing we had to do is we have a lot different software used in the different company, and we had to harmonize this. So we have to find one way to do this. I don't want to bore you with everything, but one main thing is the common data environment we have. You don't have one software. We have a few. We started with a SharePoint and A+. A+ is one thing that's actually the only platform that is accepted by the authorities for approval processes. And we needed some more. We needed a fewer. We needed a thing to work on the projects with the models. So we got the Autodesk Construction Cloud in it. And with our third partner, Engie, we brought Dialogs in it. And you see on the other side a lot of programs and software from the planners and how you do like the 4D modeling and everything. Yeah. So we try to harmonize this, and all is only go with IFC standard. Without it, it would not be possible at all. So you see now a little bit of our model of our big 5-track hall. And you see here, this is Dialogs, the software. It's actually right now used most. That's where the main model is in it. And it's actually working really good to see how in practice people working with the model. We have 250, about 200 different discipline models and 20 to 30 planners when you add all the special machine models. So it's really a lot of people to harmonize it. And how it does work with the different CDEs. So we start with Autodesk, where people work and share their models. Then it's made to IFC, and then it goes over to Dialogs, where we get it all together, do the clash detection, and then the end goes to our A+ for the approval process. That's the plans, and the plans go back to the people on site. So that's how we try to harmonize the main process. And now I go over to Daniel, who's talking about what he's doing.
Okay, thank you, Claudia. Hi, everybody. Good afternoon also from my part. I have the pleasure now to walk you through some of our use cases. But before we go into detail there, I want to show the whole picture. Because from my point of view, it shows really well the collaborative approach of the project. Because when the project started, only 4 of these use cases were required by the client. You see it there with the red line, red dotted line. And then when the project started, we sat all together on the table and decided what other use cases would be beneficial for the other partners, for the designers, for us as a construction company, and so on. And we ended up with 21 use cases, best for the project throughout the whole life cycle, starting with the digital documentation of the existing conditions, going through the design coordination, simulation and visualization of the construction phase itself, using the data from design on construction site, and also getting data back to the models from the site. And last but not least, most interesting maybe for the operating company, the operation and use of data in the maintenance phase. Of course, we don't have enough time to go through all of these use cases, so I want to focus on 4 that were really, really helpful to work together and get the best out of the data in the whole collaboration project. The first one, I think it's a no-brainer, and this use case you see in every BIM project. It's design coordination, as Claudia mentioned before, the clash detection, where we identify problems, errors in the design beforehand, not on the construction side where we have the problems, where we have delays and so on, where it costs a lot of money. No, it's already in the design phase, where you, for example, see here that in the engineering model and in the structural model, you have a cable tray running through a steel beam, not so good. Or here, mechanical model and structural model, where you have a ventilation duct in the steel structure of the ceiling, also not so good. So really helpful and good to identify it beforehand. But now, for my part, talking for a construction company, it becomes even more interesting if you link these 3D data to time-related data. Why is it so important for us? Because this is where we come from. You know, all these nice Gantt charts in complex projects having more than 800 up to 1,000 activities in them, really, really complex. If you're not a specialist, it's hard for you to understand the interdependencies, all the information that is behind it. So this is a good basis for working together? I would say probably not, because only the specialists know what to do with it. So what do we do now? What do we do then? We do these phase plans where we try to visualize how the construction site looks like at different phases in the project, draw them manually, really, really tedious and manual work. And still, it's really hard to identify the inconsistencies and problems that might arise in the construction. And it's a lot of work, especially if you have a dynamic process that's changing every time the schedule changes or the model changes, you have to do it all again manually. So what do we do? 4D. I think everybody knows it. It's when you connect the schedule to the 3D model, and then you get these nice videos where you can see in color what is being constructed right now, what is finished, maybe what is in delay. Yeah, it helps you to understand how the building is being constructed, and it helps you to communicate the problems that might arise. And also, this could be really, really time-consuming and tedious process to link it if you do it manually. So what do? We have a process, the project information structure standard, and we have these information, of course, in the model, and we also put it in the schedule. In this way, we can use rule-based algorithms to link the activities. Very, very helpful, as I said. But if I go to my construction workers on site and I show them this, they say, well, it looks nice, but it really doesn't help me in their daily work because it's not detailed enough. So this is why we identified problems where we did a more detailed 4D simulation. For example, what you can see here is the construction of these working pits underneath where the ECA trains are being maintained when it's finished. The problem was that the steel structure of the hall was already finished and constructed. And was really, you didn't have a lot of space, of course, in there to get all the equipment, machinery in there, different companies working there. So together with our work preparators and the subcontractors, we sat together and created some scenarios about the sequencing and about resource use and where to do what. And we're able to identify the optimal solution for this process. Just an example for a detailed use of a 4D model. And now the last use case I want to show is also 4D, but not only about the building, but also about the logistics, about the workspace that is available on site and the storage areas. Why did we do this? Because, again, here you have these really time-consuming manual works where you draw pictures for every week where everything is put on site, where everybody is working not to have the collision of the subcontractors on site. And also here, if something changes, the person has to sit in the office again and then do it all anew. What did we do there? We added 3D objects to the model, representing the workspace and the storage areas. And then we put the information of the company who's doing the activity in the schedule. And then with the 4D simulation, we were able to see if more than one company is working at the same time in one of these workspaces. And if this was the case, then we could see if they're competing. Sometimes companies can work together, of course. But beforehand, we could define what companies are competing and would clash. So like the red areas or spaces there, you could see their collisions. And you could beforehand identify this and prevent it. Because as we know, on site, it's really, it costs a lot to change things. And if a company is hindered and can't work, costs a lot of money. All right, this is just some examples from the use cases. Now you have learned that we have a good contract model that supports our BIM processes. We have technologies, we have everything that we need, but the most important thing is we also need the people that work with it. And there, it's a nice link to the session we had before. We are very proud that we're part of the training program, certified provider of this training here. And Weiss & Freytag has already trained almost 200 people now from within the company, from the 12,000 in total, as we have learned before. Yeah, and it's really good and helps us to get all these BIM uses, the theoretical things on site where it really adds the value into the project. And what are the next steps? Of course, we don't want to end with this project. This project will be finished next year, hopefully. We have more projects to come, as you can see here. Also, IPD projects, for example, here Residenzbahn Pforzheim, or part of the Stuttgart 21 project, Gäubahn, Pfaffensteigtunnel, where we get the learnings from the project, from Neuswerk Cottbus, lessons learned, the standards also that have been developed, and tried to adapt it to new projects, to improve and to learn every day. So I'm almost finished. The last message from my part is let's work together. We have everything that we need. We know how to do it. We have seen in practice that it adds value, that we can get something out of it. We just have to do it, get the stuff into the project, and let's work together on that. Thank you.
And the good thing is, okay, thank you. Thank you. Okay, the good thing is what I wanted to say, now we build a team, like really working practically on the project together as a project team. And now we go separate ways and take all those knowledge to the next projects. Also the other partners do the same thing. So it's a great thing to spread the knowledge by just working together in teams, sharing and going abroad, making new teams. So it's a great thing to in addition to the buildingSMART certifications to get the knowledge and get it more and more. So thank you.
Thanks, everybody.
Great. Thank you very much, Claudia and Daniel, for this insightful presentation. It is truly impressive to see how the Cottbus IC maintenance plan has been realized as an integrated project delivery project, bringing so many disciplines together under one collaborative approach in such so fast. Our next presentation is fishing for properties, sizing the mess, managing the property sets in the extension of the Federal Chancellery. Please welcome Martin Schumacher, BIM manager at BBR, and Susan Kilian, overall coordinator on behalf of BMW Bau Management Berlin GmbH. Martin and Susan, the floor is yours.
Thank you. Thank you for the introduction. Thank you. Nice to meet you. Yes, that's our project, Bundeskanzleramt Erweiterung, the short BKE, the Federal Chancellery Extension. I start with the information. The Federal Chancellery is constructing an extension to the existing building in Berlin's government district under the project management of the Federal Office of Building and Regional Planning, which is called BBR, which is my employee. So 2 decades after the completion of the main building, the extension is necessary due to a growth in tasks. Until now, employees have been spread across different locations in the whole city. In future, all work units will be united in one place. It will be in one place. The extension will form the western end of the so-called Band des Bundes, the federal ribbon, which was also designed by the architects. The architects are Schultes Frank Architekten. We have a gross floor area of about 60,000 square meters and estimated costs of about 630 million. So it's a smaller project than our predecessors, but it's not a small project at all. Yes, the concrete planning began in 2020. Following start of construction was in 2023. Actual structural work is currently being carried out on the whole site. The first finishing works for technical building equipment will start at the end of this year, at the end of 2025. Completion is estimated for 2028. So after you got the data, I show you some geometry. In the background, you can see the 5-story office building. On the right hand, you can see the airport, which is 25 meters high, 30 meters diameter, which is quite large for the helipad. And on the left hand, you can see the bridge, which has 2 stories, a public story and a story with a connection for the existing building to the extension for the staff. So it uses both. So I can show you the next picture, which shows a view from an office in the new extension towards the existing building. You see through the park by the heliport, you see they have this round concentrated working space. And in the last picture I can show you an atrium, which is a typical structure also in the existing building, and it's a real extension. It copies this and makes it along with the same surfaces and same structure as in the existing building. So, but we didn't want to see pictures, even they are nice. We talk about BIM in the project. We use BIM in planning for coordination and information takeoff. We began model-based in the LP2 with approximately 15 BIM planners for the preliminary design, and will ultimately also have integrated revision models in the end from contractors for the technical building equipment. So the BIM use cases at the beginning of geometry to synchronize the plans. As the client, I use geometric information to check the progress of the project. However, in later project phases, project partners and BIM management shift focus on property sets, and that's our theme here. We talk about fishing for properties and the problem of sizing the mesh for these properties. Our title, with its association with fishing, alludes to the challenge for the BBR of choosing the tools, which is the net, and the attributes, the fish species, in terms of their benefit for the project. Tons of bycatch that no one wants to eat bring nothing but work to the team on board. So we have therefore decided to limit ourselves to the right amount of usable property sets in the project. So now I start at the end of the chain, of the food chain, with the menu. We have specified the timing and scope of parameter provision in a MEM, a model element matrix. And the question is, what the concept behind this? We divided it in individual and global parameters. And we want to provide these parameters according to the demand. And so it's about the logistics of the project. We want to provide the parameters to the demand. So feeding the project with fish, with parameters, naturally. We start with the classic individual parameters. You can see here in IFC classes, they are subdivided in component types and have certain numbers of assigned parameters. These are strongly oriented towards the planning process. That means that they must enable ITO, information takeoff, for example, for door lists, for lightning catalogs, cost determination, and life cycle assessment. Ideally, each parameter has a customer. We have noticed that the more customers I have per parameter, and the more often it is needed, the more successfully it is integrated in the project, and the more better is the data quality. So door parameters, for example, or tendering units are very useful and a very good integration in the project. On the other hand, we have the global parameters. They are focused on the implementation phase of the project. We have defined approximately 5 parameters that allow the model components to be assigned to a tendering or contracting units. Components to be assigned to these units, a component catalog, or the AKS, BBR's own general identification key for technical equipment. Components can now be assigned to the contractors. The key for technical systems are specified by the BMS, the building management system, for implementation for the other planners. So now we have traceable links between the planners' interfaces, and they can now be documented in the model. Controllers can be provided with basis information for analyzing and controlling the construction process. Site managers can refer to catalog codes from the model for sampling and material approvals, for example. And the facility operator at last can locate the documentation for the building using the codes. Finally, all technical information can now be stored separately from the model. And the single point of truth philosophy enables us efficient data management. So how is our Einsatzplanung in German? How do we do the fishing expeditions? At the end of every planning phase, we defined data jobs at which mandatory checks were carried out by the BIM overall coordinator to control the project quality. However, data jobs with mandatory checks within the planning phases are more important in order to ensure profitable data management between and exchange between the planners. So, for example, parameters that allow ITO for costs and tendering should be available already during execution planning. So the number of data jobs with mandatory checks increases in the higher project phases. So if we have the Einsatzplanung, we have to choose the net. We started with visual inspections, which was at the beginning of the project with less parameters and less geometric complications, followed by checking with proprietary software to have a similar geometric and information checkup. And last, finally, we do the checking with IDS, the buildingSMART information delivery specification. These sets were also accessible to the planners, so we gave them the sets to control their work by itself. And so openBIM could be implemented in our model because we have a lot of different softwares, and so we could unite their quality control. After we choose the net, we have to size the mesh to get the right amount of information by limiting ourselves to a few global parameters. At the end of the LP5, the LP8, we want to obtain models with high data quality. We dispense with data that was important in the planning phase and is now provided via the documentation with greater precision and more reliability. So global parameters connect in our last phases these two worlds. So now we are for the practical application of the tools. Susan will tell you the details.
Thank you. Hi, I'm Susan. I'm the overall coordinator for the project, and I will show you how to use the net. At the beginning of our project, we start in phase 3 and also in the beginning of the phase 5 with using the parameters from the MEM, Martin told you, and we make a rule set and Solibri to use it and to check the information. And at the middle of the phase 5, we want to make a change because we want to make it easier for ourselves and also for the participants of the project. And between that, we select the requirement components and also the description of the requirements. And you see it here on an example as on a wall. And we use the parameters and the classification of the wall to make our checking list.
Of course, the one question that we all ask ourselves, how do BIM models play a role in such a project that is actually truly GIS project? And the answer is quite simple. As Max previously said, this organization, TENET, and in this case, NOL project, defines the BIM information management, BIM as BIM information management, and not BIM information modeling. So it is very important to understand that we have different types of data, and they all, such as CAD data, GIS data, and also some models, and they all need to work together and follow and consistent and transparent information management. And although we are not so detailed when it comes to LOD in this project, for example, compared to a singular building, the higher stake is actually in the documentation requirements, what are very important. We do, apart from the route, we also have some other infrastructure elements, such as link boxes, cable section stations, or even some bigger structures, DC switch gear, that is actually, so to say, a parallel project for itself, and DC converter, like a typical 3D building construction, where the collaboration and, of course, the clash detection are going to be undertaken as well. So you would ask yourself, okay, and how did we actually implement BIM as a building information management? And where do we stay right now? As a typical thing, we started with a digitalization strategy. This document, the set of guidelines, included, among other things, actually the methods. How do we combine GIS, BIM, and even lean management? And we've identified the existing data structure and new ones to be developed, as Max previously shown to us the existing ones. We also defined the CDE requirements, and of course we actually put a great effort into setting under collaborative boundaries based on the fact how the digital awareness is going to be presented in the project team members. This document also included the management requirements. And those requirements, I think everyone here knows also this graph. It's a ISO 19650 that we actually used a solid frame for the management requirements definitions. But there is one thing. It couldn't be to 100% applicable in this project. Why? Actually, in particular, it comes to the AAR. We have a partnership project here, so the AAR couldn't be brought to the project just in front because this document has to be done together with the future contractor, and this is all first possible if the one is being chosen and has become all the assessment center. Entschuldigung. But furthermore, as Max previously said and shown you, we have an asset information model, and typically for the architect, it's more or less a 3D model with all the information. But actually, as Max also previously presented, we do have this OTL data set, and has to be a little more being understood as a knowledge graph that actually combines all the elements, all the information about the asset that are going to be designed. And one of the things that we actually developed within this information strategy is our BIM platform. So it's actually a central platform for bringing together and managing information between all the project participants in this partnership. And this is like a very brief IT architecture, I would say. And not without reason, we haven't placed here any of the names of the software, because we think that this solution needs to work no matter which kind of document management system we do apply. And the core set of this solution is this data hub asset management, as my colleague Max shown before. What the platform does, it does maintain the data structure, those named OTL and SPS across systems. It is quite flexible. It has to be flexible, because as we know in the partnership project, the contractor is going to be chosen afterwards, and he comes with his own solution, and we need to probably develop some kind of interface to his modules. And we do have the modules that within the software that actually provides the different use cases or the views of the data that are going to be visualized. And of course, we do want to have an end-to-end information model and provide the management of this information within the responsibilities for the necessary services. What is more, and what was actually the main purpose of this so-to-be-named BIM platform, it was the collaboration. We wanted to have a solution that all the chosen project workflows were based on the reliable data and could be executed. And this solution follows also this functional requirements such as information management, data provision, information verification, and of course, single source of information, single source of truth, and the execution of automatic workflows, and of course, metadata-based workflows. Where are we now? We have started, I would say, 1 year ago, a little bit more. And we are right now heading into the direction of December 2025, in which the contractor is going to be onboarded, becomes a BIM kickoff, and we will see how he is going to contribute to the requirements and to the BIM platform. We also brought some learning for you. There's one smart sentence, I would say. The digitalization requires a new focus on technology and people. And those two solutions have to be agile. I mean, the people and the technology. The people need to be open to collaborate and to understand the future developments, and of course, bring already to the table some kind of digital awareness. Thank you very much.
Great. Thank you, Yagen. Thank you very much, Max.
Thank you.
And Malgorzata. Thank you for sharing your perspective on how BIM, GIS, and link data are shaping the future of our industry. Let's move on to our final presentation of this session. It is building digital twins, how asset administration shell and IFC standards together are transforming the construction industry. Please welcome Dr. Kai Oberste-Ufer, Senior Manager at Dormakaba and member of buildingSMART Germany, together with Christian Frey, Vice President of Industry Affairs at Siemens, Smart Infrastructure and representative of the Industrial Digital Twin Association, IDTA. The floor is yours.
Thank you very much. Thank you very much. Yeah, first of all, also warm welcome from my side. My name is Kai. As we already heard in the introduction, I'm part of buildingSMART Germany, and together with Christian today, we are talking about, of course, working together. And working together can not only happen, as we heard previously, among different projects, among different parties. It can also work between buildingSMART and other organizations. And that's what we are going into this last session or this last presentation of this session. And by the way, I think we have kind of the most awkward name for the presentation. It's not really catchy, but anyway, it's exactly what we are talking about. It's building digital twins, how the AAS, and what this is, I will explain later, and IFC, you should know that, standards together are transforming the construction industry. Content, yeah. I will talk a bit about digital twins in construction, and I know when you talk about digital twins, it's always a hot political topic because everyone sees it a bit different. What is a digital twin? How is it interpreted? There are different stories around that, and don't kill me at the end. I'm just trying to convey here our view of the world. Then I'm talking about BIM and AAS, asset and production data, hand over everything to my colleague, to Christian, about the details of the asset administration shell, and then hopefully some meaning and useful closing thoughts that you can take home, at least in the coffee break. I already talked about the digital twin. I said, yeah, it's a hot topic. And when you look at the digital twin definitions, and here are a couple of them, not only today, but also throughout the history, it changes. In the past, sometimes a 3D model was already considered as a digital twin. Question is this really still the case? So if we look at some definitions, for example, from ISO, saying it's a digital representation, it has data connections. Siemens is talking about real-time data, about real information coming from the live building, coming from the assets in the building, and that's also already also picked up by the IDTA. So there is probably more than just a static 3D model when it comes to the digital twin. I mean, we can discuss this, we can dispute, we can fight about that, but roughly that's it. When we talk about the digital twin and what to do, we thought, okay, maybe we set up our own definition. And our own definition, I put on top buildingSMART. It's probably not buildingSMART International. It's probably our definition here. A digital twin is a digital representation, that's important, including product, machines, and use cases. So we are not just talking about 3D data. We are not just talking about dead structures. We are talking about something that lives and something that includes everything in a building. It includes also smart sensors to collect data, to bring in this dynamic approach, this vivid, dynamic data approach that is probably missing in other definitions. And also, they should exchange data. So the twin is not just something like a big bucket of data, just collecting things, useless, sitting somewhere in an IT landscape. No, it is something we should use that is actively communicating that we can use to create a better building. So if we talk about the hunt for the digital twin, and it's a nice hunting session we have today, because we had this fishing topic in the last session. Now I'm talking about hunting, and that was not, somehow we didn't talk about that building, but this picture. But at least it makes, I think, some kind of sense. So when we talk about the digital twin, of course, we have our world. We have the world of the building. We have the world of IFC. We have the world of BIM models. And from my perspective, this is an ideal support for that what is happening when we look at the building when it's in operation. Here we have suddenly not just the structure, we have suddenly assets, we have machines, we have HVAC, we have all the equipment that really brings the value of the building. I mean, it's not just an empty skeleton, it's really something that we need to operate that brings value and functions for the people, for the building itself. And as I said, I think it's a perfect match we have here, and we have probably not really make use of that. The BIM structure is something that is the foundation to really create a comprehensive digital twin, including every data asset and every part of the building. So, and why did buildingSMART International think this is a great idea? Now, I mean, if you look at our process, and this is an oversimplified process, but I get you know it, we are talking about design, engineering, construction, reuse maybe at the end. So this is our world we are quite happy with, and we are earning money in. And we have several BIM approaches. We talked about Loin, we talked about different phases where data is used. I simplified it by saying, oh, we have something like a design BIM, and don't kill me for that term as well. And we have something facility BIM, more tailored to be used in the facility management system. And then we have product data, because products are used in a building, and products or assets is that what a building creates or gets its value from in its combination. And these products may be blurry at the beginning, not really specified what it is, and it gets even clearer throughout the design and engineering process. And even at the end, if you look at the last one, it's maybe deconstructed and used in a circular economy we're all moving to. This is our world. This is our playground. This is why we are so active. That is why we are here. But then we have this. In a galaxy far, far away, something was happening. And we thought, what about the digital assets? What about the products? What about the products someone is producing for a factory, for equipment? And they have, if you look at the products, the same kind of steps in its life cycle. So we have a design phase, we have production. We are not really constructing something, but it's production. We have commissioning. The thing must go in the building and be switched on and integrated. We use it and then we recycle it. But that sounds already or looks already familiar. So we have also here, we have to distinguish between type data. I want to have, I don't know, a TV. And then instance data, where it says, okay, we have this particular TV or HVAC system or whatever in my building. So also here, the information, the granularity, the detail level gets finer while you move on in the life cycle of the product. And now, of course, let's merge things. So if we have on the one hand side the demand for data coming from the construction side, and we have on the other hand side the supply of valid information, and we heard a lot this morning about the DPP, which is definitely going in this direction to to support the demand of information. And in the middle, we have the AAS, the Asset Administration Shell, which is a server, a system, but Christian, you will talk about that later on more in detail, which does exactly this: hand over data from, or connect data coming from the building with data, detailed data for product information. And buildingSMART International signed a partnership, cooperation contract with the IDTA, which is the Industrial Digital Twin Association. And outcome, and this contract was signed in end of 2024. And already after a couple of months, we already created our first tangible result, which is a guideline, Deutsch Leitfaden, how to connect these two things. How to connect a building with information stored in the asset administration shell. But that's exactly the point where my competence runs out of fuel, so to say, so I hand over to Christian.
Thank you very much, Kai. Before I start, I would like to wake you up with two questions. Who of you has heard about the asset administration shell before? Hands up. Okay. And who could explain it to me? Okay, at least one. Yeah, okay. It is about the building life cycle, because 80% of the life cycle cost of a building is spent in the operation. So you have to think in the design phase already, how would I like to operate the building, and what does my facility management need? So far, when we look at this, we have this life cycle. It starts with a digital construction twin. So this is actually the model, as we have seen it many times here. And this is only for the walls, for IFC wall, IFC ceiling, IFC slab, and all these things. But no building is running without products. We have lamps, we have speakers, we have lots of things here of building automation, and all these products must be described that deliver data that we need in the design phase, but also in the operation. So, and this is all static data. So you get a value that describes a length or the function of a product, but that is not enough for the operation phase. In operation, we need live data, dynamic data, and this comes via this performance twin, as I call it. Okay, so it bridges the asset administration shell bridges the digital model with the real world. That's the way it works, and it already starts in the commissioning phase, and I come to this later. So, as said, we have the skeleton, it's described in IFC, which is a standard, you all know, and we have the AAS, which is the nerve system, actually, of the building later on, and it's also described in a standard, because this is important. We need to have this standard in order to have a standardized access, vendor-neutral access to all this information. And now what we did, and you saw we have already this guideline, we bring these two standards together. IFC and AAS, perfect match from the static BIM to the dynamic AAS intelligence. So, this is the asset administration shell, how it looks like, defined in the standards. It's the IAC 63278, and it's defined by the IDTA. And luckily, we also have the general manager of the IDTA today with us, Mike Billman. Is he still in the room? Okay, I will introduce you to him if you are interested. And so the two standards are working together, and as Kai already mentioned, we have a type where you describe the function of the asset, and when it goes into commissioning, after commissioning, you have the instance, which means you have the serial number, you know exactly where the location is, and so on. And this is important to know where is my asset. Where can I find it? And this is a big problem in facility management. And even if you found it, where is the documentation? How can I replace this product? Are spare parts still available? So all these are questions, and the construction and the architects, they do not care enough for facility management. So they leave them alone, and they have to generate all this information from scratch, more or less. So that's why it is important that we really hand over this, the BIM information to the facility management, that we exactly show where is the location of an asset inside the building. What you see here is also the live data. You see on the left, on the left-hand side, yeah, the blue stuff. That is the description of the asset administration shell. Don't worry, there is a generator that brings all this information together. And as you can see, we have different protocols inside. You can also have a vendor neutral access to all this information. So this is a Siemens product, but it can be also any other product. And the good thing is we have a submodel content description that gives you a lot of information from this, or actually all the information from this product delivered by the manufacturer. Single source of truth. That's important. And as you can see here, we even can measure the energy consumption of the building, or of a story, or of a machine, of a data center, or whatever you would like to see, also with historical data. So this is what I mean, getting live data out of your BIM model in order to know what's going on, and in a standardized way, vendor neutral. So, okay, and this is just for the energy. You can also have it for temperature, for humidity, whatever you would like to connect. And yeah, from design to handover, as I said, it already starts in the commissioning phase. You see here a presence detector described by an asset administration shell. Now, just imagine you have a room, a toilet. When you enter the toilet, your presence is detected and the light goes on. Today, somebody has to sit down, do the programming. Well, if presence detector 1 connected to controller 1 detects a presence, please switch on light 1 to 4. As we have all the information in the model, let's take AI do this job, because in future we won't have skilled workers that can do that anymore, okay? So let's use AI to analyze the model. What do I have in this room, in this space, IFC space, okay? And then I find the toilet, and I find the presence detector. In the same room, I find 4 lamps. So the controller is pre-programmed already. With switching on, you won't find the people to do this anymore in future. So we need to go to new technologies. And this is what is provided with the asset administration shell, all this information. And it's not only for the presence, but it's also for temperature, that you know what sensor, temperature sensor, controls which heating ventilation system, and so on and so on. So it makes our life easier, makes it more reliable in the construction, and so and many more things. And one more I forgot to explain before is also carbon footprint. Today, we struggle all to get a carbon footprint of our assets. How much carbon is in a screw? How much carbon is used in, I don't know, a smoke detector? So, because at the end of the day, we have to sum it up and to find all this information out of a PDF, forget it. It won't work. It's a long, long Excel list, doesn't work. With the asset administration shell, you get this reliable data from your manufacturer, directly from the manufacturer, and he's responsible for the data, not the planner that types it from a PDF or any other document. No, you get this information. And I hope that the politic will also see this and say, well, this guy used a product with this carbon footprint. And 80% of this product can be reused. So I get a reduction of my carbon footprint calculation if I can reuse this product. We discussed it with SBB. I know the colleague from SBB is also here about the rail track. When you can reuse this iron for the avalanche protection, then it can be deducted in your carbon footprint calculation. So now I have 18 seconds left. My last slide. Stop handling over USB sticks with Excel and PDF. Go for the asset administration shell. Have a standardized access to all the data that you need, not only static data, but also dynamic data, that you can operate your building in the most efficient and reliable way. Save time, get all the life cycle information, and what we are working on at Siemens is also the autonomous building. And for us, it's mandatory that we have all this data at the right place. Okay, so this was quite fast and short information, but on Wednesday, if you are interested, you can get more about it in the ballroom 2. I don't know where this is, but we will find it's over there. Okay, I'm happy to see you there. I hope we have enough place. Thank you very much for your time.
Great. Thank you. Thank you both for this forward-looking perspective on how IFC and asset administration shell standards can enable true digital twins. Now this concludes our session, working together. Today we've seen that whether it's delivering complex buildings, managing critical data, or shaping the future of digital twins, one thing is clear, that only by truly working together, we can move forward, just like IFC and asset administration shell. Collaboration across people, disciplines, and standards is the key that will unlock the next level of our industry. So a big thank you to all our speakers for sharing their expertise and experiences with us. And thank you all for your attention. We will now take a 30-minute coffee break before the next session. Enjoy the break.